Hi, good afternoon, everyone. I'm very glad to to share some ideas about the research on the security analysis technology for blockchain smart contract. So I'm come from the Information Security Lab of the Computer Science Department, School of EECS in Peking University. First, I would like to give a very brief introduction about our lab. So regarding to the blockchain related issues, our lab are the initiator of and the leader of the open source project. It's called GMSSL, and it is covered the encryption algorithm with the open source implementation. That encryption algorithm come from China. So EMSSL is very popular in the worldwide. If some people would like to deploy the Chinese version of the encryption algorithm into the blockchain system. And we are also an associate member of Ledger in Linux Foundation since 2018. This lab 5 PhD students and 5 master degree students. They work in the blockchain and the blockchain security area. And right now we have 6 master degree students graduate and 1 PhD student graduated this year. So his name is Liu Chao, and he's also the team leader of the team. They wins the first prize of the Tokyo Long Hash blockchain hackathon in the April of 2018. Yeah, so here we'll have some brief introduction about the work. Mostly is my PhD student Chao Liu and the group to do some research related to the smart contract security technology and tools. So I would like to introduce some research background about smart contract security and the current status and some main ideas and some research content and achievement from our research group. Then we have some conclusion about that. Well, so people work in the blockchain area, the smart contract is a kind of application running on the blockchain architecture platform. So compare with some other applications and the technical features of the smart contract application, they have the open and transparent and the guaranteed execution and non-tamperable and the various specific features is not depend on the trusted third party. So throughout the smart contract, the blockchain applications, they extend to most scenarios like digital currency and the financial asset transaction and settlement, and also digital government. So the government services is also based on the blockchain, and also anti-counterfeiting, the data sharing and data services. Yeah, those application scenarios are most related with the smart contract. So therefore, there is a high security requirement for smart contract. So if that contract defect it can cause major property or the data losses. So there is also the kind of big security event related to the digital currency, like in the year 2016, the digital asset of the door, the smart contract, were stolen due to re-entry loopholes that result in a loss of almost 50 million US dollars or equivalents. So therefore, it's how it can ensuring the security of smart contract is critical to the credibility of blockchain applications. Well, there is some challenges. Things you may know. There is a different kind of runtime environment and different platform. The most research focuses on the Ethereum, so it's a kind of a special runtime environment with some gas resource mechanism, exception handling mechanism, and persistent state, etc. Well, there is also various source threats, such as security breaches, abnormal transactions, etc. And also the state space expand rapidly. So certain vulnerabilities need to capture specific transaction sequences, such as the transaction order dependent. Well, some general idea covers these three parts. One is vulnerability discovery technology for smart contract. So those will deal with how to improve existing vulnerability discovery technology to meet the application's needs of different scenarios. And other part is anomaly analysis technology for smart contract. So throughout the clarify anomaly classification and find anomality features and identify the cause of anomality is also quite important. So how we can build a security analysis tool set for smart contract is also needed to fit the gap in security analysis tools to promote the practical application of related tools. Well, the current research status, even in recent 2 or 3 years, there are some achievements to deal with such kind of issues. So we can see that regarding to the security vulnerabilities, so there is some publications to cover the security vulnerability classification. What are the security vulnerability and what are their characteristics? So some publications shows for that topic. And another part is security vulnerability detection. Some technology tools was developed like Orient, Contract Fuzzer, and Securify, Max, etc. So it covers how to discover hidden security vulnerability in smart contracts throughout static program analysis or dynamic program analysis technology. Well, the third part is security vulnerability exploitation. So this is also how to exploit the security vulnerability exposed by the smart contract. And also the fourth part is security attribute verification, how to detect and verify security attributes throughout model checking or theorem proof. Yeah, there's also some research around this topic. So here we highlight some publications related to the topics. We can see that the security vulnerability detection research mostly focusing on the known pattern vulnerabilities. And the security attribute verification research normally rely on the manual definition of rules. Well, regarding to the normally analysis, there is most topic here listed. There is some publications deal with that part. For example, the gas resource mechanism optimization and the gas resource consumption optimization and the gas resource consumption estimation and anomaly related vulnerability detection that covers how to find abnormal related vulnerabilities hidden by smart contract. So, for example, the inconsistent exception vulnerability, etc. So here list some publications to cover these list of the topics, and we can see that there is some more attention paid to the gas exhausting anomaly and the lack of research on other anomaly types. So they are focusing on the gas resource estimation and optimization, but the lack of analysis of abnormal courses. Well, to a summary that in order to ensure the security of smart contract, the current research works has the following limitations. So one is vulnerability discovery, that they focus on the known pattern vulnerabilities and rely on the manual definition of rules. So for the anomaly analysis, it's still lack of overall understanding of the anomaly and the lack of analysis of the course. Well, some research ideas come from the limitation and the lack of such kind of attention for the research. So in our lab, and even for this, the research group, there are many focus on the, how we can have the multi-theme integration, practical smart contract vulnerability discovery, and the system framework. So how we consider the cross-platform, cross-application, and even compatible with a different type of vulnerability discovery technology. The second research direction is that semantic driven systematic smart contract transaction abnormal diagnosis method. So how to deal with the automated process, understanding of transaction semantics, and the balance of precision and the efficiency. Yeah. So here is some research point on the such kind of multi-theme integration practical smart contract vulnerability discovery system framework, and some research points under the semantic driven systematic smart contract transaction exception diagnosis method, and some research achievement that under the security analysis tool set build up to okay. So we can see that the smart contract oriented vulnerability discovery technology that is intended to support the security vulnerability detection, prediction, and the search. Well, for the smart contract-oriented anomaly analysis technology, our research that covers to have to clarify the classification of smart contract exceptions and discover features of smart contract exceptions and diagnose the reason of smart contract exceptions. Okay. So let's go through some detail about these three research directions. So the first one is smart contract vulnerability discovery technology. Well, normally the smart contract vulnerability discovery problem that can have such kind of research to get the vulnerability mode or pattern information to build the repository. And we take a smart contract as input and to generate a vulnerability report. Actually, there is three vulnerability discovery scenarios. So vulnerability discovery technologies. Yeah. So let's see that if from the vulnerability discovery sub-issue, we can see that there is detection, prediction, and search. So for the detection, the input will be source code or the bytecode of the smart contract. And so the vulnerability mode type is normally for the detection, we have a known vulnerability with clear pattern. So for this way, the output results we would like to have, is there a loophole inside? So that is a discrete value. So we call such kind of solution in our system called SFAST. Well, for the vulnerability prediction, the input format is still source code, but we only have the unknown vulnerability or known vulnerability with unclear patterns. So throughout this way, we would like to have a security breach threat. It's a probability value. So we call this kind of solution as the name of SGRAM. For the third part, the vulnerability search, the input format is a bytecode. So vulnerability mode type is also known vulnerabilities. So the output results we would like to expect is that whether there is a vulnerability or not. So that is also a discrete value or probability value. So we call this solution the name as clone. Well, throughout the vulnerability detection technology based on the fuzzing logic or fuzz testing, so we need to convert the smart contract to be throughout the code parser to get the intermediate code. Then the smart contract code converter can convert it to be C+ target contract code and with based on the runtime library. So throughout and also throughout the contract transaction, we can get the runtime trace and the coverage. The runtime trace goes through the code core vulnerability detector and to generate a vulnerability report. So that report covered the vulnerable code location and exploit the code. And the coverage going to the fuzzing engine and throughout the random byte stream and throughout the contract transaction, then we can to do the discoveries. So this is suitable for the vulnerability detection with clear signature patterns. Well, so for the vulnerability prediction technology based on the language model called the S-gram. So here that is suitable for the vulnerability prediction with unclear feature patterns. So there is a training corpus and the contract to be tested. They go through the model training stage and the model prediction stage throughout the token generator and the static analyzer to get the semantic information and the token sequence. Well, then go through the vulnerability detector and the language model training engine to generate the candidate sequence. So the candidate sequence go to the function sorter to get the security threat value. The most sophisticated vulnerability analyzer to generate the security breach. Well, so this is kind of the tools S-gram to deal with the vulnerability prediction with unclear feature patterns. Well, for the S-clone, that is vulnerability search technology based on the similar code. So the smart contract and the smart contract with the known vulnerability contract library. So we can combine them together to get the contract information summary. Then they separate into the grammar information summary and semantic information summary. Then they go through the similarity code detection. Yeah, so throughout the similarity calculation and the clone detection, then finally generate the answer, yes or no. So use the similarity of the contract code to search for known vulnerabilities. Well, the smart contract abnormal analysis technology, they covered some issues here. So smart contract abnormal classification, yeah. And the gas exhausted, stake overflow, and illegal instruction, and insufficient transfer balance, or other types. So I'm not going to some details about that, but yeah, this category is also to get more attention and to try to deal with that. So among these explicit state rollback exception and gas exhaustion exceptions are the most common issues. Well, so for the smart contract abnormal analysis technology, so they go through the empirical research on the abnormal smart contract. So throughout, for example, the data collection to get the synchronized Ethereum to get Ethereum, the client or web crawler, and to import into the data set. Then go through the stage 2 in empirical analysis, so we can get the basic facts and the exception reason. Then using tools to do the evaluation, so the tools support the official compilers. So in general, this is use historical transaction data to explore the basic characteristics, courses, and the processing method of smart contract exceptions. Well, for the basic facts, the abnormal distribution, they covered the three category. First one is explicit state rollback and the gas exhausting account for the majority. And the average external transaction triggers multiple smart contract exceptions. And also there is also denial of service DOS attacks that can generate a large number of gas exhaustion exceptions. So here shows some exception type and the times and the percentage of the oral transaction as external transactions here. So, well, and have the smart contract abnormal diagnosis technology. So it's based on the symbolic execution. So the abnormal transaction track that goes through a symbolic execution engine and to get the contract source code and the source map. So throughout the symbolic execution engine, they can generate the path condition, a path constraint. So the path constraint can go through the abnormal diagnosis analyzer, and they can generate the abnormal reason. So S-trace is used to the abnormal transaction track to analyze the diagnosis of the cause of abnormality. Well, the third part is a smart contract security analysis tool set. So the tool set, we can see that we combine the vulnerability detection tools as fast and the vulnerability discovery tools as GRAM, and the vulnerability search tools as clone, and the abnormal analysis tools as trace to form a core analysis model. So based on the support component model, like the fuzzing engine, code conversion, language model, lightweight static analysis, similarity calculation, and embedded vector extraction, and abnormal diagnosis, and symbolic execution engine. So such kind of support component model. So we build the core analysis model. So this tool set is quite easy to use. It's user-friendly. They can provide user interface model. It's a web service based. And also it provides command line options. Yeah. So so this is the framework that can integrate multiple tools to provide a solution as a whole. And also they can support the 4 types of security analysis scenarios. So here shows the interface of the smart contract security analysis tool set throughout the web service interface, so we can see enter the contract, and they can get some results which quite easy understand for the interface. And also the command line interface, they can doing like this, so it's quite easy for the programmers or testing engineer. Well, here is a shows the whole ideas, and based on this smart contract security analysis tool set. So we can have the smart contract. They go through the process, vulnerability detection, vulnerability prediction, and vulnerability search. So after that, then go through the blockchain runtime environment throughout the symbolic execution. So they can we can do the anomaly analysis throughout the S-trace. So you can use combined tools for the vulnerability detection, and also to do the analysis of abnormal smart contract after the deployment. Well, in summary, that for the S-fast, S-gram, S-clone, there is show some results even for the tool. They have some improvement compared with the current existed tools and the algorithm. So it provides the security and vulnerability analysis in efficient way. So they have fewer false positive and false negative results for the S-fast, and even higher accuracy for the S-gram, and achieve some balance between the accuracy and the recall for the S-clone, the vulnerability detection, and also the accurately diagnosis of the cause of abnormality, right? Well, in summary, we can see that so this research they have some main contribution is about the there is a 3 security vulnerability discovery technology for smart contract are proposed, which can support the application requirement of 3 types of scenarios, like vulnerability detection, prediction, and search. So it summarizes classification and occurrence mechanism of smart contract anomalies, conducts empirical research on large-scale real transaction data, summarize the characteristics and the main reasons of abnormality during runtime, and propose a diagnosis technology for the abnormality during smart contract runtime. And it's also combined the two together as a tool set, and to verify the effectiveness of the tool using real smart contract data, right? Well, I think it's only the some progress, and the future research is still quite expected. For example, how we can improve the existing security vulnerability discovery technology, and to support more type of vulnerabilities, and to combine the latest technologies in related fields such as the BRT language model and the CNN or GNN related works. And they need also further study of the characteristics of abnormal transaction track, such as contract core relationship mode, and explore more runtime abnormal analysis problems. And finally, how we can improve the security analysis tool set to optimize the existing code, to expand the data test data set, and to promote the practical development of the tools. Well, here is some highlights of the research in of our small research group. They have some work during the last 2 or 3 years. Here listed the published papers that we cover the most topics I have introduced before. So if you are quite interested in some research directions, please reference to the papers and go through the details. Attention.
Oh, okay. Thank you for the wonderful talk. Here is a question from one of the audience. Yeah. Can the tool provide suggestions to debug the smart contracts if the code is wrong?
So the question is that if the code is wrong, how? Yeah. So I think that this is another category of the problem. Yeah, it's debugging issues. Yeah. So here, my topic is covered if the topic is a smart contract is good, and it can pass a compiler, and how we can detect some bugs or vulnerabilities here. So for the code, the wrong code, maybe they are throughout the compilers and the program compiling technologies, they can help to solve that kind of problem. So we do not deal with such kind of things as the security analysis issues, right?
Okay. Thank you again, Professor Chen. The next talk is at 6 o'clock. Okay, see you later.
Okay.